Hello, let's try to understand limit of a function as it approaches infinity. Here are three examples before us, right? These are basically, if you see the first one there, first two are the exponential functions, right? And the last one actually is tricky. Okay, the first one says limit of 7 over x to the 7 over 5 to the power of x. As x approaches infinity, what happens to this function? We have to see the number base for which the exponent is x. Here the base is greater than 1. So remember exponential functions? If the base is greater than 1, then the function actually increases, right? Kind of like this, right? So as x approaches infinity, the function also approaches infinity, right? So for here, we can say the limit does not exist, right? Because it does not approach a fixed value, right? 0 is a fixed value, 7 is a fixed value, but infinity is not a fixed value, and we can never reach there. Therefore, we see here, as x approaches infinity, the function 7 over 5 to the power of x also approaches infinity, and so it does not approach a fixed value. We say the limit does not exist. Now how about this? 4 over 5 is less than 1, right? So if something is less than 1, in that case, the exponent, as x increases, it approaches 0. Kind of like this, right? So for this kind of a function, we will say that the limit is equal to 0, right? So if the base is less than 1, in that case, the limit as x approaches infinity will be 0, right? Because you're approaching 0. Now here, the last one is limit of a function which is pi. Pi basically is constant function, right? It doesn't ever change, right? So it is a line like this where the value of the function is always pi. Is it okay? So for this, the limit is pi, whether you are infinity or at any other point, right? So these are interesting examples where we have a limit of a function as it approaches infinity, right? You can have some more very interesting is our reciprocal function, right? So reciprocal function is 1 over x, correct? So for 1 over x, for example, you can find the limit of the function when, so you can do this, right? You can find limit as x approaches infinity for 1 over x. This you can try, right? Now 1 over x, you can sketch a graph and it approaches 0, correct? So, or sometimes we may straight away write, well, L always for the limit should be a lowercase. I wrote uppercase here, but you should take precaution writing a limit with lowercase, okay? X approaches infinity, we could have 1 to the power of, let's say, 3 to the power of x, correct? So this is same as writing this is same as writing limit of x approaching infinity for, let's say, some value 5 to the power of minus x. Do you see? So minus x to the power means 1 over, in this case, it will be 1 over 5 to the power of x. Now as in this particular case x increases, approaches infinity, the denominator becomes very, very large, and 1 over infinity tends to be 0, correct? So in this case it will be 0, here also will be 0, and here also will be 0, correct? All these functions, it will be 0. So there are many cases, interesting cases for the function as it approaches infinity. We will take up rational functions in another video. Have a look at that and see and try to find out what really happens when we compare the degrees of numerator and denominator. That may sometimes or always will give us hint what the limit should be as function approaches infinity, okay? And as you see, limit approaching infinity helps us in calculus, in advanced functions, to find horizontal asymptotes, right? These are all, if you see, if limit is 0, it means that the horizontal asymptote is 0. A function is approaching 0 as we approach infinity, correct? And infinity could be plus infinity or minus infinity also, correct? So both cases I could have given you problem with, but well, now what you can do is you can change all these questions to limit x approaches minus infinity and find out your answers, right? That'd be a good exercise for you. Okay, try to sketch them also. These are very simple and interesting cases. I hope you enjoy it. Thank you.